Okay, question 40. We're looking at an overall reaction that takes place in a galvanic cell as shown below via this equation. Part A, we need to determine the oxidation number of lead in lead oxide and lead sulfate. So let's have a look. So first I'll just write the oxidation numbers above each reactant and product. So we've got here our lead solid. If we remember our pure elements, we'll have an oxidation number of 0. So we've got 0. Then oxygen has an oxidation number of -2, that above it. There are 2 oxygens, so that would give it a -4. And when we've got a compound, overall it needs to be neutral, which would give this lead a +4. Okay, moving on, let's have a look over here. So we've done lead oxide, and we've got lead sulfate. So again, we know that this was where a few people got tricked up. If you split this, okay, it's an ionic compound. So if we remember that a charge of a sulfate ion is -2, okay, because that's polyatomic anion, and that would mean that the lead would have to have a charge of +2, okay, because if you were working out the oxygen by itself, which is -2 with the 4 would be -8, you wouldn't then be able to work out what the sulfur was and what the lead was. So if you think of the sulfate as the whole anion, so that is a -2 charge, you can work out what the lead is. Okay, so if we have a look at these oxidation numbers before we go to the next question, we've got lead solid, okay, is going from an oxidation number of 0 to +2. Okay, so that's an increase in the oxidation number. So an increase in the oxidation number means it's undergoing oxidation. And then this lead here in the lead oxide is going from +4 to +2, so it's decreasing. So that would tell us that that one's undergoing reduction. Let's have a look at question B. Deduce the oxidation and reduction half equations. Okay, so we need to come up with each half equation taking place at the negative lead electrode, that's the anode, and the positive lead oxide electrode, which is the cathode. Okay, so it's telling us that the positive lead oxide electrode, which is the cathode, so that's here, is undergoing reduction. Okay, and that's what we can deduce from those oxidation numbers, which we did in part A. And we've got our negative lead electrode is the anode, so that must be undergoing oxidation, which it is. It's increasing oxidation number. So let's write down the equation at the anode to begin with. If I can write properly. Okay, so we've got our anode. So we've got lead sulfate, solid lead. Okay. Okay, let's have a look at this equation. So it's going from 0 to +2. Okay, I'll leave a gap so we can fill in what we're missing. Okay, P, B, S, O4, and that's a solid. Okay, so if we go back to our balancing redox equations, remember the COs, so key elements first. So I've got my lead, one lead, I need my sulfate. Okay, and if we have a look back up at the equation, we've got sulfuric acid, H2SO4, is aqueous, okay, which tells me that it can ionize in solution. So that means that I could have my hydrogen ions and my sulfate ions. So that means I can separate them from my equation. So then I can have my SO4 2 minus, okay, if we remember that's the charge we worked out before. So I've got my lead plus my sulfate would give me lead sulfate. Okay, so that's balanced so far, that's aqueous. Okay, so I've got my key elements. My oxygens are balanced, there's no hydrogens to balance. Last stage was my electrons. So I've got 2 negative here, and this here is neutral. I need it to be, so 0, I need it to be the same either side, but I can only add negative numbers. So over here, if I add 2 electrons, Okay, that means that that is a balanced half equation for my oxidation at the anode. The next reaction occurring is my cathode. Excuse my really bad writing with this. Okay, so my cathode was told me here I've got lead oxide electrode. Okay, so that's this species here. So I've got PbO2 solid. Okay, and I'll leave a gap so I can fill it all in. And it's again going to the lead sulfate. Okay, PbSO4 2. Oh, I'm doing that. Don't need to do that there. Solid down here. Anyway, myself. Okay, so I've got my lead oxide and lead sulfate as products. Now I need to go through the COs and balance it. So let's have a look at our key elements first. So I've got my lead, one lead. Okay, don't have my sulfate. If we remember before from our anode equation, this here, my sulfuric acid, was aqueous. So I can just add my sulfate ion. So I'll add my sulfate ion, SO4 2 minus aqueous. Okay, so that's my key elements balanced. Now I need to balance my hydrogen, my oxygens. Okay, so I've got 2, 4, so 6 oxygen, but I've only got 4 this time. And we're going to balance our oxygen by adding water. Okay, so if I add, really bad writing, I need 2 more waters this time. So I've got 6 oxygen each side. Okay, let's check. So, oh, it's an L. 2, 6, 4, 6. Yep, okay, my oxygen is balanced. Now I need to go to my hydrogens and make sure my hydrogens are balanced each side. So this side I've got 4 hydrogens. I've got none this side. So I'll add my 4H plus. Okay, and that is aqueous. Okay, and the very last step was my electrons. So this side, neutral, neutral. So overall the charge of the electrons is 0. Here I've got 4 positive and 2 negative. So that's overall 2 positive. Okay, but this side is 0. This is 2 plus. So I need to add 2 electrons. Running out of room. Okay, to make the electrons even each side. Okay, the charges. So this is, I've done, that's my reaction at my anode and my cathode. Next it says deduce the oxidizing and reducing agents. Okay, so if you remember, if something undergoes oxidation, it's a reducing agent, and something that undergoes reduction will cause oxidizing. Okay, so if I grab a different color pen, okay, point to options in color blue. Okay, so here we have got this here would be our reducing agent, and here we've got our oxidizing agent. Okay, oxidizing agent. This is here, reducing agent. Really bad writing. Okay. Then state the direction of the electron flow between the electrodes. Okay, and remember that electrons will always flow from the anode to the cathode, from negative to positive.